My friend, have you ever stepped outside late at night, looked up at the sky, and suddenly felt small? Not in a sad way, in a mysterious, almost spiritual way. Like the universe was whispering, "Hey, you're a part of something much bigger." We see stars. We see the moon. We see a tiny slice of reality. But what we don't see is the vast ocean of space stretching in every direction, filled with galaxies, black holes, cosmic storms, and secrets older than time itself. And there was one man, trapped inside a failing body, who dedicated his entire life to uncovering those secrets. Stephen Hawking. Let's talk about Hawking for a second. At 21, he's diagnosed with ALS. Doctors tell him he has 2 years left to live. Imagine that. Imagine being young, brilliant, ambitious, and being told, this is the end of your journey. Most people would give up, break down, let life swallow them. But Hawking didn't collapse inward, he expanded outward. As his muscles stopped working, his imagination grew stronger. As his body shut down, his mind opened up the universe. By the time he wrote A Brief History of Time, he could barely move a finger, yet he was exploring black holes, the birth of the universe, the nature of reality, and questions even Einstein couldn't fully answer. That contrast alone gives me chills. A man who couldn't lift a spoon lifted the veil on the cosmos. The questions that keep humanity awake. What makes this book powerful isn't the formulas or the equations or the physics. It's the questions. Humanity's oldest questions. Where did everything come from? Why is the universe the way it is? Is time real? Could the universe have been totally different? Do black holes destroy information? Is the universe infinite, or does it loop back on itself? Is there a before the Big Bang? Do we live in a multiverse? And my favorite, why does anything exist at all instead of nothing? These are not just scientific questions. These are emotional questions, philosophical questions, spiritual questions. And Hawking takes these huge ideas and turns them into a story anyone can follow, even a kid, even someone who hates physics, even someone going through a rough time. Why this book still matters today. We live in a world where attention spans are shrinking, but anxiety is growing, where everyone is overwhelmed by daily stress, money, relationships, identity, expectations. I sometimes think Hawking wrote this book to remind us that our lives, with all their chaos, are happening on a tiny blue dot floating in an infinite dark ocean. Your heartbreak, your worries, your overthinking, they matter, but they exist inside a universe so much larger and stranger than anything we can imagine. And that perspective is healing. It's grounding. It's humbling. Hawking isn't just teaching physics. He's teaching perspective. He's teaching humility. He's teaching us to look up instead of looking down. Let me tell you something fascinating. In 1964, 2 scientists, Arno Penzias and Robert Wilson, were testing a giant radio antenna in New Jersey. They kept hearing a strange noise, like static. No matter what they did, the noise wouldn't go away. They thought it might be pigeon poop on the antenna. They cleaned it. Still static. Finally, they realized the truth. They had accidentally discovered the leftover radiation from the Big Bang, the oldest light in the universe, still echoing today. It was like hearing the universe's baby cry, 13.8 billion years after birth. This discovery confirmed the Big Bang theory, and Hawking used it as one of the foundations for the ideas in this book. A mistake became a revelation. It's wild how often science works like that. Hawking once said, "My goal is simple. It is complete understanding of the universe, why it is as it is, and why it exists at all." That's what this book is. Not a textbook, not a lecture, not a list of formulas. It's a man, a deeply curious man, trying to answer the biggest question humans have ever asked. Where do we come from, and where are we going? And he wants to take you with him. He wants you to understand the universe as if you're sitting with him in his living room, talking like friends, sharing cosmic secrets. That's the energy we're bringing into this series. Together, we're going to break down the Big Bang, the shape of time, black holes and Hawking radiation, quantum mechanics, the multiverse, the arrow of time, the mystery of singularities, the end of the universe, and the possibility of time travel. But not in a complicated way, in a storytelling way. The way Hawking wanted people to learn, with curiosity, wonder, and humility. And now, let's go back to the moment before stars existed, before light existed, before time existed. To a universe smaller than a grain of sand, yet containing everything we will ever know. This is where our story begins. My friend, if you really want to understand the universe, you have to be willing to go to a place where nothing makes sense. And I don't just mean nothing as in confusion. I mean nothing as in literally nothing existed. No stars, no planets, no light, no time, not even space. Just nothingness. It's crazy to even imagine, right? Because our brains evolved on Earth, a place full of trees, sunlight, air, and noise. We're not built to understand nothing. But scientists like Hawking, they attempted anyway. And somehow, they figured out how the entire universe began. Imagine you're holding a grain of sand on your fingertip. Now imagine the whole universe, every galaxy, every star, every atom, compressed into something even smaller. That tiny point is what physicists call a singularity, a place where the laws of physics break down, where density is infinite and time hasn't begun yet. The universe didn't explode into space. It exploded into existence. Before the Big Bang, there was no where, no when, no outside. Time itself was born with the Big Bang. This is one of Stephen Hawking's biggest ideas. Time and space came into existence together. Without the Big Bang, there is no clock ticking, no past, no future, just stillness. We often imagine the Big Bang as a huge explosion, boom, fire, noise. But that's Hollywood talking. In reality, it wasn't loud. There was no air for sound, no atoms yet, just pure energy expanding outward. The Big Bang wasn't a sound. It was a spreading, like a ripple forming across a cosmic ocean. And in less than a fraction of a second, the universe expanded faster than the speed of light. This moment is called inflation. It's the universe going from invisible microdot to a space the size of a basketball in a blink. It's insane. But we know it happened Because the universe still carries the echo of that expansion. Scientists literally see the Big Bang's afterglow in the microwave background radiation. Remember the story I told you earlier? Those two scientists who thought pigeons were causing static? Yeah, they accidentally detected the universe's baby picture. That static is the oldest light in existence. This is the question that breaks people's brains. Why does anything exist at all? Why isn't there just emptiness? Hawking had a beautiful answer. Quote, "Spontaneous creation is the reason there is something rather than nothing." In quantum physics, even nothing isn't truly nothing. Even in a perfect vacuum, particles appear and vanish constantly, borrowing energy from the universe and returning it instantly. The universe, in a way, borrowed energy to create itself. It popped into existence, the same way tiny particles pop in and out of vacuums, but on a cosmic scale. Some scientists call this quantum magic. Hawking called it quantum inevitability. Humans have always tried to explain the beginning. Ancient India had the concept of Brahman, a timeless, shapeless reality from which the universe emerges. The Greeks imagined chaos turning into order. The Egyptians believed in a cosmic ocean and a lotus blooming into the universe. The Vikings believed fire and ice collided to create the world. Every civilization tried to answer, where does everything come from? Hawking didn't destroy these stories. He added clarity to the mystery. He showed that the universe didn't begin with a god placing a star in the sky or a cosmic egg cracking open. It began with physics, with laws, with energy, with time itself awakening. We are made of that explosion. Every atom in your body, the carbon in your lungs, the calcium in your bones, the iron in your blood, was forged in the heart of exploding stars billions of years after the Big Bang. So when Hawking explains cosmic origins, he's not explaining something foreign. He's explaining our ancestry. We are not separate from the universe. We are the universe, thinking about itself. Atoms made into consciousness. Stardust given memory. Matter given emotion. And that is why Chapter 1 hits so hard. The beginning of the universe is also the beginning of us. Time. The one thing every human feels, but no one truly understands. We live inside it, we measure it, we chase it, we waste it, we fear it, but what is it? You can touch space, you can measure distance, you can weigh matter, but time? You can only feel it passing. This is why Hawking spends so much time, ironically, trying to explain time itself. And the more you learn about it, the stranger it becomes. Let's break it down together. Time isn't universal. It's personal. Bro, one of the craziest things Einstein discovered is that time moves differently for different people. Not emotionally, literally. Imagine you and your friend both start clocks at the same time. You sit still. Your friend gets in a spaceship and flies near the speed of light. When he returns, your clock will show more time passed than his. He will be younger than you. This isn't science fiction. It's called time dilation, and it's proven. We even tested it using 2 atomic clocks in 1971, one on the ground, one on a plane. Guess what? The clock that flew around the Earth ran slower. Tiny difference, big implications. Time isn't a universal river. It's a personal river, flowing at different speeds depending on how you move. This means your time is different from someone else's. Mind-blowing. Gravity bends time. Not only speed, gravity also affects time. The stronger the gravity, the slower time moves. This is why astronauts on the International Space Station age slightly faster than people on Earth, because Earth's gravity slows time. If you live on the top floor of a skyscraper, you age microscopically faster than someone on the ground floor. Even your feet age slower than your head because they're closer to Earth's gravity. Bro, time is bending all around you without you even noticing. Why does time move forward? This is one of Hawking's biggest questions. Why does time only flow forward? Why can't it go backward? Why can't we unbreak a broken glass, or unsay harsh words, or ungrow older? Hawking explains this using entropy, the measure of disorder in the universe. Think of a clean room versus a messy room. Clean, low entropy. Messy, high entropy. The universe naturally moves from order to disorder. You don't have to try to make things messy. It happens on its own. Similarly, time moves forward because entropy increases forward. The direction of entropy is the direction of time. This is called the arrow of time. Once you understand this, you understand why we can't go backward. You can mix milk into coffee, but you can't unmix it. You can burn paper, but you can't unburn it. You grow older, but you can't grow younger. Time isn't pushing you forward. Entropy is. A real-life example, why memories only go one way. Here's something Hawking loved to point out. We remember the past, but not the future. Why? Because the past has low entropy, less chaos, more order, and the future has high entropy, more chaos, more unknown. Your brain can store memories of order, but you can't store memories of something that hasn't happened yet because the entropy hasn't unfolded. Could time travel be possible? This is where things get crazy. According to Einstein and Hawking, time travel to the future is absolutely possible. Just travel near the speed of light. Time will slow down for you while Earth continues normally. But what about the past? That's where things break down. To travel backward in time, you'd need infinite energy, negative mass, or to break causality, all of which violate physics, as far as we know. But some theories, like wormholes, suggest it might barely be possible. Hawking himself proposed chronology protection, a law of nature that prevents backward time travel so the universe doesn't fall into paradoxes. Because imagine, you go back in time and stop your parents from meeting, then you were never born. But if you were never born, who went back in time? These contradictions are why nature likely forbids it. Time started at the Big Bang. Hawking's most mind-shattering point: before the Big Bang, there was no time at all. Asking what happened before the Big Bang is like asking what's north of the North Pole. There is no before. It doesn't exist. Time was born with the Big Bang. And one day, if the universe collapses back into a singularity, time will end, just like a book with a first page and a last. Why this matters to us. My friend, this isn't just science. This is a reminder. Your time is limited. Your time is personal. Your time flows differently than anyone else's. Your time shapes your reality. Hawking once said, one of the basic rules of the universe is that nothing is perfect. Perfection simply doesn't exist. And maybe that's why time moves forward, to let us grow, change, heal, and rewrite ourselves. If time could go backward, we'd never evolve. The universe isn't just sitting there like a giant room full of stars. It's actually stretching, growing, expanding every second. Not like an explosion flying outward, not like stars drifting through empty space. Something much stranger. Space itself is stretching. Like fabric being pulled, like dough rising in an oven, like rubber being stretched, carrying galaxies with it. In 1929, astronomer Edwin Hubble made an observation that changed everything. He noticed the farther a galaxy is, the faster it is moving away from us. Every direction he looked, galaxies were running away like scared birds. Imagine standing in a field, and no matter where you look, every tree is walking away from you. Impossible, right? But that's what Hubble saw. This wasn't the galaxies moving through space. This was space itself expanding and carrying galaxies like raisins inside a rising loaf of bread. Okay, friend, imagine a balloon. Draw tiny dots on it. These are galaxies. Now, blow air into the balloon. The dots don't move on their own, but as the balloon expands, the dots get farther apart. This is our universe. We're not at the center. Every point experiences expansion the same way. This is why galaxies look like they're running away from us. But if you were on another galaxy, you'd see the same thing. This is not motion. This is growth. Here's where it gets crazy. People ask, can galaxies move faster than the speed of light? And the answer is no, but space can. Galaxies inside that space just get dragged along. This is allowed because, 1, nothing is moving faster than light, and 2, the space itself is expanding. Light has a speed limit. Space does not. Wild. Just like ambulance sirens drop pitch when they move away from you, light also changes when galaxies move away from galaxies. This is called redshift. When something moves away, light stretches, becomes redder. When something comes closer, light compresses, becomes bluer. Every distant galaxy Hawking studies is extremely redshifted. This means they're speeding away from us as space stretches. Redshift is a cosmic receipt, proving the universe is expanding. Remember the static sound Penzias and Wilson discovered in 1964 when they thought pigeons messed up their antenna? They had accidentally discovered cosmic microwave background radiation, the leftover heat from the Big Bang. This radiation is everywhere, even in the empty night sky. When you see static on old TVs, a small part of it is literally the echo of the Big Bang. This radiation is stretched, cooled, and spread across the universe because of expansion. It's like the universe is saying, I was born, and here's the proof. If the universe is expanding, then rewinding that expansion leads back to a single point, a beginning, a starting moment, a birth. This is how Hawking and other scientists proved the universe once existed as a tiny, ultra-hot singularity. But here's the twist. If the universe is expanding today, what will it do tomorrow? Scientists have 3 theories. Expansion continues forever. Galaxies drift apart until stars die, energy spreads thin, the universe becomes dark and cold. This is the universe growing old. Gravity pulls everything back. The universe collapses into a singularity again. Then, a new Big Bang might follow. A cycle. Birth, death, rebirth. Like cosmic reincarnation. Space expands so fast that atoms themselves are ripped apart. Galaxies to stars, to planets, to molecules, to atoms, all torn into nothingness. A terrifying but fascinating idea. There's something strangely comforting about knowing the universe is expanding, Because everything in life expands too. Your knowledge expands. Your mind expands. Your experiences expand. Your identity expands. And sometimes your problems expand too. But Hawking teaches something beautiful. Expansion is not chaos. It's evolution. It's growth. It's the universe moving forward, exactly as it should. You're not meant to stay small. You're not meant to stay the same. Growth is natural. Expansion is natural. Even the universe is still stretching from a spark that started 13.8 billion years ago. And so are you. There are places in the universe where the laws of physics break, where time stops, where space folds in on itself. Places that even light, the fastest thing in existence, cannot escape. These places are black holes. And if the universe were a story, black holes would be the villains, the mysteries, the silent monsters. But ironically, Stephen Hawking spent most of his life proving that these monsters are full of secrets and even beauty. Let's enter the darkness together. Imagine a star, not our sun, something much bigger. A star may be 30, 50, or 80 times more massive. When such a giant star runs out of fuel, it collapses under its own gravity. It falls inward, tighter, smaller, heavier, until all its mass is crushed into a point with infinite density, a singularity. Around this singularity is a boundary called the event horizon. And this is the point of no return. If you cross it, you never come back. Not because you're pulled, but because escape becomes mathematically impossible. Let's visualize it simply. At first, you wouldn't feel anything strange. Gravity would be strong, but not painful. As you get closer, time slows for you, slows dramatically. An outside observer would see you move slower, slower, eventually freezing in place at the event horizon. But from your perspective, time feels normal. You fall through the event horizon without noticing anything unusual. And then you hit the region where gravity becomes violent. So violent that your body stretches like spaghetti. Scientists literally call it spaghettification. Your head is closer to the singularity, so it is pulled harder than your feet. You stretch, thin, long, until atoms themselves tear apart. It's the most extreme death the universe has to offer. But here's the crazy twist. If you survive long enough, you might see the entire universe's future in a single moment. Because time behaves differently inside. Falling into a black hole is like watching the universe fast forward to its end. Most people think a black hole is like a vacuum cleaner. Wrong. A black hole doesn't pull anything. Instead, space itself is flowing inward like a waterfall. Imagine a river. You're floating downstream. It's calm at first. But ahead is a waterfall. No matter how hard you swim, you can't escape the pull of the current. That's the event horizon. Once you pass it, the current becomes unstoppable. everything is carried downward. Not because the water sucks, but because the river flows. Black holes work the same way. Space flows inward. You flow with it. For centuries, scientists believed black holes were completely dark. Nothing comes out, not matter, not energy, not light. But Hawking changed that forever. Using quantum physics, he discovered black holes glow. They release energy. They release radiation. This is called Hawking radiation, one of the most important discoveries in modern physics. Here's the simple version. Empty space is not empty. Particles and antiparticles pop in and out of existence. Right on the edge of a black hole, these pairs sometimes get separated. One falls in, the other escapes. The escaping one becomes radiation. This means black holes slowly evaporate. They die. This shocked the scientific world because it meant that black holes are not eternal. Even the universe's monsters have a lifespan. This is where science meets philosophy. When something falls into a black hole, does information get destroyed? Physics says information can never be lost. But black holes swallow everything. And if black holes evaporate, where does the information go? It's like burning a book. Physics says the information is never fully gone, only scattered. But black holes? They seemed to erase the book entirely. Hawking spent 30 years thinking about this. Some said information escapes. Some said it's stored on the event horizon. Some said reality splits into parallel universes. In 2016, after decades, Hawking finally proposed, information is not destroyed. It comes out in a scrambled, unreadable form. So nothing in the universe ever truly disappears. Not stars, not matter, not ideas, not memories. Everything leaves a trace. Even us. Black holes aren't just cosmic monsters. They're metaphors. They represent the unknown, the fears we avoid, the parts of ourselves we don't understand. Hawking's message is simple. The darkest places in the universe are full of knowledge. Sometimes the places we fear the most, the failures, the mistakes, the traumas, contain the greatest lessons. Black holes look destructive, but they're also creators. They shape galaxies. They power quasars. They influence the universe's evolution. Darkness isn't always the end. Sometimes it's the beginning. We often think of space as empty, a black nothingness, a void. But that's not true. Space isn't empty. It's not nothing. It's a fabric, stretchable, bendable, twistable. And time isn't separate from it. Time and space are woven together into a single cosmic cloth called space-time. This idea changed physics forever, and understanding it will forever change how you see the universe. Before Einstein, people believed gravity was a force, something objects used to pull on each other. Newton's law made sense. Objects attract. Simple. But Einstein said, no, gravity isn't a force. It's the bending of space-time. Here's the easiest way to visualize it. Imagine a giant trampoline. Put a heavy bowling ball in the center. The fabric curves downward. Now roll a smaller ball near it. It moves toward the bowling ball, not because it's pulling, but because the surface is curved. That's gravity. Matter tells space how to curve, and curved space tells matter how to move. Elegant, beautiful, genius. Every choice you make, every step you take, every moment you live creates a curved line in space-time called a world line. Even when you're not moving, you're still traveling through time. Sitting still doesn't make your world line straight. You're still curving through the fourth dimension. This is why time changes depending on speed, gravity, motion. Your life is physically a path through the universe. You are drawing your story on the fabric of reality with every passing second. You might not feel it, but the Earth's mass bends space-time around it like a dent in a mattress. That's why the moon orbits Earth. You stay grounded. GPS works. Time runs differently at different altitudes. Black holes exist. Without curved space, nothing would orbit anything. No planets, no galaxies, nothing. Gravity isn't a pull. It's a curve. People think relativity is science fiction. No, my friend. It's literally in your pocket. Your phone uses signals from satellites in space. But here's the twist. Gravity is weaker up there. Time runs faster for satellites. Without correcting for relativity, GPS would be wrong by 10 kilometers per day. Your phone would have no idea where you are. Technology only works because space and time are curved exactly the way Einstein predicted. This is where Hawking takes Einstein's work and pushes it further. People ask, if the universe is expanding, what is it expanding into? Hawking's answer is simple. The universe doesn't need an outside. Space can be curved without needing a boundary. Think of the surface of the Earth. It's curved, it's finite, but it has no edge. You can travel forever without falling off. The universe might be the same. Finite, but unbounded. Curved, but edgeless. This is extremely hard to imagine because our brains evolved in three-dimensional space. But reality? Reality doesn't care about what's easy to imagine. When the universe began, time was compressed, tight and small, like a tightly rolled spring. As the universe expanded, time unrolled with it. Just like space can curve, time can also slow down, speed up, twist, stretch, almost stop near a black hole. This is why Hawking says, time is not a constant background. It is a dynamic part of the universe. Time is alive. It reacts. It bends. It participates. In 1919, Einstein's theory was tested during a solar eclipse. Light from distant stars passed near the sun and bent slightly. When scientists measured the deflection, it matched Einstein's equation. This made Einstein a global celebrity overnight. Newspapers called him a magician. The world was shocked. Gravity? Bending light? Impossible. But true. This bending is happening everywhere, every moment, all across the universe. Because black holes, wormholes, the Big Bang, the end of time, all of it only makes sense once you understand one thing. Space and time are not separate. They are one connected fabric. Once you see that, the universe becomes less mysterious and more beautiful. Everything is connected. Everything affects everything. Every atom affects space-time, and space-time affects every atom. You are part of that fabric. Your existence isn't small. It literally shapes the universe around you. My friend, when you understand that space and time are flexible, dynamic, alive, you realize something powerful. Nothing is fixed. Nothing is permanent. Everything can bend. Everything can change. Even the universe is constantly reshaping itself. And so are you. Your reality, your identity, your future, all of it is flexible. You are not rigid. You are not stuck. You too exist in a space that can change shape. Hawking's message is simple. If space-time can bend, so can your life. We're about to enter a world where nothing makes sense, but everything is true. A world where particles teleport, where things exist in two places at once, where certainty dies and probability rules. This is quantum mechanics, the science of the very small. And Stephen Hawking believed that to understand the universe, you must first understand its tiniest building blocks. Let's dive in. When we shrink down to the level of atoms and particles, the universe stops behaving like the universe we know. The laws we learned in school, they break. Instead, particles behave like waves, clouds, probabilities, illusions, flickers of existence. It's not like physics changed, it's that reality is stranger than we ever imagined. At the quantum scale, certainty dies. Only probability survives. And Hawking loved this chaos. Let me tell you a story that made scientists question reality itself. More than 200 years ago, a simple experiment changed everything. Here's how it works. Take a wall with two tiny slits. Shine light or electrons at it. Watch the pattern formed on another screen. If particles were like tiny bullets, we'd see two lines. But instead, we see an interference pattern, waves overlapping like ripples on water, meaning light behaves like a wave. Okay, cool. But then scientists tried something shocking. They fired one electron at a time at the two slits. Just one. Guess what happened? Still, an interference pattern. One electron acted like a wave going through both slits at the same time. It gets crazier. When scientists observed the electron to check what it was doing, the wave collapsed. The electron behaved like a normal particle. Two lines. No interference. Meaning, when you watch reality, it changes how reality behaves. This is quantum mechanics. Here are the key rules. Rule 1. Particles don't have a position until measured. An electron isn't somewhere. It's a cloud of probabilities. It only becomes a thing when you observe it. Rule 2. Particles can be in many states at once. This is called superposition. Think of it like this. You're both happy and sad, confident and unsure, calm and anxious, until someone asks how you feel. You collapse into one emotion when measured. Particles do the same. Rule 3. Particles can be instantly connected. This is entanglement. Einstein called it spooky action at a distance. Two particles can be linked so that changing one instantly changes the other, even if they're on opposite sides of the universe. Distance doesn't matter. Speed of light doesn't matter. It is the universe's deepest mystery. And it's real. We've tested it thousands of times. 4. Hawking's big question. How do quantum and gravity fit together? Einstein described big things: planets, stars, galaxies, black holes. Quantum mechanics describes small things: atoms, electrons, photons, quarks. But these two theories do not agree with each other. It's like the universe is written in two languages that contradict each other. Hawking spent decades trying to unify them. This became the foundation of quantum gravity and the theory of everything. Hawking believed that black holes were the key to uniting these theories, because inside a black hole, gravity becomes incredibly strong and quantum particles are everywhere. Black holes are the intersection between Einstein and quantum chaos. 5. Quantum tunneling. The universe teleports. Quantum particles don't follow rules. For example, a particle can appear on the other side of a barrier it didn't have enough energy to cross. This is called tunneling. Imagine you try to walk through a brick wall. Impossible, right? Quantum particles do it every second. Without tunneling, the sun wouldn't shine, atoms wouldn't form, your body wouldn't exist. Quantum weirdness is not rare. It's the foundation of everything. 6. Virtual particles. The universe is never still. In empty space, particles constantly pop in and out of existence. Here, gone. Here, gone. Borrowing energy from the universe for the tiniest fraction of a second. These particles create Hawking radiation, influence gravity, and shape the universe. And they exist everywhere, even inside your room right now, even inside your body. 7. Why this matters to us. My friend, quantum mechanics is not about particles, it's about uncertainty. And life is full of uncertainty. Quantum physics teaches us things can exist in many states. The act of observing changes reality. Small changes create huge results. Connection can exist across impossible distances. And unpredictability is a feature, not a flaw. Hawking believed the universe is not a rigid machine, but a dance of probabilities. And so is life. You don't have to know everything. You don't have to be certain. You don't have to be predictable. Uncertainty isn't weakness. It's nature. The universe itself runs on it. My friend, if there's one question that haunts humanity across all ages, all cultures, all beliefs, it is this: where did everything come from? And where is everything going? Stephen Hawking spent his life trying to answer these two questions. And in doing so, he gave us a story that is bigger than any religion, bigger than any myth, bigger than any philosophy. A story written in light, in gravity, in quantum chaos, in the silent language of the universe. We've talked about the Big Bang before, but now we go deeper. At the beginning, all matter, all energy, all space, all time, all laws, all possibilities were compressed into a point, smaller than an atom, but heavier than a universe. This point is the primordial singularity. And then, for reasons science is still uncovering, this point began to expand. Not explode, expand, faster than the speed of light. This moment is called inflation, and it's the reason space looks so smooth and uniform today. Imagine blowing up a balloon so fast that any wrinkles vanish instantly. That's what inflation did. Here's the shocking truth. According to Hawking, this question makes no sense, because time was created with the Big Bang. Asking what was before the Big Bang is like asking, what's north of the North Pole? There is no north beyond the North Pole. There is no before beyond the beginning of time. Hawking believed the universe has no boundary. It is finite, but without edges. Time itself curved at the beginning, like the top of a globe, smooth, finite, with no outside. This is called the no-boundary proposal, one of Hawking's most revolutionary ideas. After the Big Bang, temperatures were trillions of degrees. Particles appeared and vanished. Space boiled with quantum energy. Forces were not separate yet. Matter and antimatter annihilated each other. But then, things cooled, and as the universe expanded, it developed structure, like clay cooling into shape. Here's the timeline. 0.000000000001 seconds. Forces separate. 3 minutes. Atoms begin forming. 380,000 years. Light breaks free. Cosmic background radiation. 1 billion years. Galaxies begin to form. 13.8 billion years. You are here. Your body, your mind, your entire existence is the latest chapter of this story. Why is there something instead of nothing? This question is so deep that philosophers debated it for 2,000 years. Hawking's answer is bold. Quantum laws make creation inevitable. In quantum physics, energy appears from nothing. Particles pop into existence. Space is never truly empty. The universe didn't need a cause. It didn't need permission. It didn't need an outside creator. The universe creates itself from the laws of physics. This is not philosophy. It's math. Just like humans, the universe has a life cycle, and Hawking considered 3 possible endings. 1. The Big Freeze. Most likely, the universe expands forever. Galaxies drift apart. Stars die. Black holes evaporate. Eventually, no heat, no light, no energy, no life. Everything becomes cold darkness. Have you ever wished you could go back in time? Back to a moment you regret? A moment you miss? A moment you didn't know was important until it was gone? Every human understands this feeling, but nature doesn't allow it. Time moves forward. Always, relentlessly. In this chapter, Hawking explains why. And it has nothing to do with clocks or calendars or physics textbooks. It has to do with the universe's personality. Here's the strangest thing. The laws of physics don't care about direction. They work the same forward or backward. A falling glass and an unbreaking glass are both allowed in the equations. So why, in reality, does the glass never unbreak? Why can you remember yesterday, but not tomorrow? Why do you grow older, but never younger? This is the mystery of the arrow of time. To understand time, you must understand entropy. Entropy is a measure of disorder. The more chaotic something is, the higher its entropy. The universe naturally moves from order to disorder, low entropy to high entropy.
This is not a choice, it's a rule. It's the only rule the universe always respects. A room gets messy easily. That's entropy increasing. But a room does not clean itself. That would decrease entropy. Life moves toward chaos. Meaning moves toward noise. Structures fall apart. Heat spreads. And because entropy increases, time moves forward. The arrow of entropy is the arrow of time. The three arrows of time. Hawking describes three arrows. 1. The psychological arrow. Time moves forward because your mind remembers the past, but not the future. Memories give direction. Your brain is wired to store past information and predict future possibilities. If memories reversed, your reality would reverse. 2. The thermodynamic arrow. This is entropy. The universe gets messier over time. Heat spreads. Order becomes chaos. A broken egg doesn't unbreak because that would reduce entropy. This arrow is the strongest. 3. The cosmological arrow. This is the expansion of the universe. As long as the universe expands, time flows forward. If someday the universe collapses, the Big Crunch, time could reverse, but Hawking believed humans will not exist to see such a reversal. Here's the simple truth. To reverse time, you'd have to reverse entropy. You'd need to unmix coffee, unburn paper, ungrow a tree, unbreak a glass, unage a human, unexpand the universe. But the universe doesn't allow large-scale decreases in disorder. Time is tied to entropy like a train is tied to tracks. You cannot turn it around. Black holes complicate things. Inside a black hole, time does strange things. Time slows. Time bends. Time stretches. At the center, time may not exist at all. Some theories even suggest that at the singularity, past and future lose meaning. But Hawking believed time does not reverse even inside a black hole. It simply becomes twisted and stretched beyond recognition. Your brain is a biological machine that increases entropy when it stores memories. This is why you remember yesterday, not tomorrow. Because for a memory to exist, your brain must create structure, using energy, making heat, raising entropy. Therefore, memory only works in the direction entropy increases. Psychology and physics are connected by entropy. My friend, it is about life and change and the one-way nature of existence. Hawking's message is simple. You cannot go back, but you can go forward. Time's direction is what allows healing, growth, rebirth, evolution, forgiveness, and learning. If time could reverse, nothing would mean anything. Hawking once said, "Without the arrow of time, we would have no way to distinguish the past from the future." Living is not about going back. Living is about using the arrow of time to become something new. Just as the universe evolves, so do you. Entropy increases. Life moves on. Time flows one way. And that is okay. Because the story of the universe is written forward, not backward.
There's something beautifully human about the idea of wanting to understand everything. Not parts, not fragments, not pieces, everything. The entire universe, from galaxies the size of cities to particles smaller than imagination. And this is what physicists call the theory of everything, or TOE. A single equation, a single framework, a single elegant truth that explains every force, every particle, every law, every beginning, every ending. Stephen Hawking spent decades chasing it. Let's explore this impossible dream. Imagine you're watching two movies that should be connected, but the subtitles don't match. One story says one thing, the other says something else. This is the universe. It is governed by two theories that both work perfectly, but contradict each other completely. Movie 1. Einstein's General Relativity. The world of the big. Planets, stars, galaxies, black holes, gravity, space, time. This theory is smooth, elegant, predictable. It treats the universe like a calm, perfect fabric. Movie 2. Quantum mechanics. The world of the small. Electrons, photons, quarks, subatomic chaos, uncertainty, probability. This theory is wild, unpredictable, full of randomness. It treats the universe like a cosmic casino. They cannot both be right in the same place. Where do these two worlds collide? Inside black holes and at the Big Bang. And this is exactly where Hawking worked. Think about it like this. The laws of nature created everything. Your heartbeat, the stars, the oceans, DNA, black holes, time, light, gravity, chemistry. It would be strange if these laws were disconnected. There must be one underlying structure holding everything together. The theory of everything is the universe's master script. Hawking explained that the universe runs on four forces. 1. Gravity. The weakest force, but shapes the cosmos. 2. Electromagnetism. Controls atoms, electricity, chemistry. 3. The strong nuclear force. Holds the nucleus of atoms together. 4. The weak nuclear force, responsible for radioactive decay. Physicists have unified electromagnetic plus weak to electroweak theory, and strong with quantum mechanics to quantum chromodynamics. But gravity refuses to join the party. It's the outsider, the lone wolf. And that's the main obstacle in creating a theory of everything. There are three major contenders. 1. String theory, perhaps the most famous. It says everything in the universe is made of tiny vibrating strings. Different vibrations give different particles, like musical notes on a cosmic violin. String theory requires extra dimensions, 10 or 11 or even 26 dimensions.
Not just up, down, left, right, but invisible dimensions curled into tiny spaces. Beautiful idea, but still unproven. 2. Loop quantum gravity. This theory tries to quantize space-time itself. It says space is made of tiny loops, atoms of space, pixels of reality. It removes singularities and works well with quantum mechanics, but struggles with gravity on large scales. 3. Hawking's approach. No boundary and quantum cosmology. Hawking believed the universe didn't need separate laws. Instead, he argued, space and time are finite, without boundaries, governed by quantum rules. In his view, the universe creates itself from the spontaneous laws of physics. No edge, no before, no outside. The laws are the creator. This approach is elegant, but still incomplete. Hawking once asked, if we find a complete unified theory, will there still be room for God? He wasn't attacking faith. He was asking something deeper. If the universe writes itself, who wrote the laws? A theory of everything isn't just science. It's philosophy. Its meaning, its purpose, its existence itself. Because the universe at large scales is smooth and predictable, but at small scales, it is chaotic and random. Trying to combine the two is like mixing oil and water. Hawking said, we are trying to understand the mind of God. And by God, he meant the ultimate blueprint behind reality. Near the end of his life, Hawking came to a profound conclusion. A perfect theory of everything may not exist. Why? Because the universe might be too complex, too self-creating, too quantum, too interconnected. Instead of one neat equation, we might need multiple models, like layers of an onion. And that's okay. The universe doesn't owe us simplicity. Reality might be bigger than human logic. My friend, this is not just about physics. It is about meaning. The theory of everything is humanity's search for purpose, unity, a story that explains all stories, a truth that explains all truths. Hawking teaches us life is not about knowing everything. Life is about the search. The beauty is not in the answer, but in the question. The universe is not a puzzle to solve. It is a mystery to explore. And every one of us, curious, flawed, human, is part of that exploration. You and I, just like Hawking, are trying to understand how everything fits together. Your life, your choices, your struggles, your dreams, they're all part of the universe's story.
My friend, we've traveled through a lot together. We've walked through the birth of time, the stretching of space, the fires of stars, the darkness of black holes, the chaos of quantum particles, and the mind-bending geometry of space-time itself. But now, we arrive at the real question. What does all of this mean for us, for humanity, for you, for me? Hawking spent his entire life searching for the ultimate laws of the cosmos, and yet near the end, his message changed. It became softer, more human, more personal. When you look at the night sky, you might feel small, a single human in a universe 13.8 billion years old and 93 billion light-years across. But Hawking flips that idea completely. He said, you are away for the universe to understand itself. You are not separate. You are made of the same atoms that were forged in stars billions of years ago. You are literally the universe becoming aware. You are not small, my friend. You are rare. Some people look at the vast universe and think, it's too big, too old, my life means nothing. But Hawking believed the opposite. Meaning isn't given to you by the universe. Meaning is created by your choices. The universe doesn't tell you why you exist, but it gives you the freedom to decide. And that is power. You are not meaningless. You are the author of your part of the universe. Hawking believed that consciousness, the ability to think, to question, to imagine, is the rarest phenomenon of all. In billions of galaxies, on billions of planets, life is possible. But consciousness, awareness, curiosity, that is almost miraculous. You are the universe gaining the ability to ask, why? And that question is the beginning of wisdom. Despite all its beauty, the universe is dangerous. Gamma rays, supernovas, black holes, asteroids, entropy, heat death. The universe is not built to protect us, but Hawking believed that intelligence gives us the tools to survive, to adapt, to expand beyond our planet. Hawking said, "There is no heaven or afterlife, but there is plenty we can do before the universe ends." Humans may be fragile, but our ideas can outlast stars. To Hawking, hope wasn't something soft or emotional. Hope was fuel. Hope was survival. Hope was evolution. Hope is why early humans looked at fire and said, "We can control this." Hope is why we crossed oceans, climbed mountains, created telescopes, built rockets. Hope is why Stephen Hawking kept exploring the universe, even while trapped in a wheelchair with a failing body. His voice came from a machine, but his mind traveled across galaxies. Hope is the most powerful force in the cosmos. Near the end of his life, Hawking shared 3 messages for all humans. 1. Look up at the stars, not down at your feet. Stay curious. The universe rewards curiosity. 2. Work hard. It gives you meaning. Intelligence without effort is wasted. 3. Never give up. No matter how hard life seems, there is always something you can do, some way to move forward, some light in the darkness. These words carry more weight coming from a man who could not move, could not speak, could not hold a pen, and yet still became a global symbol of genius. My friend, you are not here by accident. You are not lost. You are not behind. You are not meaningless. You are a conscious, thinking, feeling piece of the universe. You matter because you exist. Your questions matter. Your dreams matter. Your curiosity matters. The universe is full of chaos, but your life is where meaning begins. Hawking's work is not about stars and equations. It is about understanding that even in a cold, indifferent universe, you have the power to create warmth and purpose and connection. You have the power to tell your own story. And today, you and I told a part of the universe's story together.